Hello everybody, welcome to my channel. Today we have an amazing problem for you guys, right? It's called subtree of another tree, right? So this is a very, very good problem, so make sure you pay close attention, right? So it says given the roots of two binary trees, root and subroot, right? Return true if there is a subtree of root with the same structure of nodes values of subroot, right? And false otherwise. So it says a subtree of a binary tree, right, is a tree that consists of a node and tree and all of its nodes descendants. The tree could also be considered as a subtree of itself, right? So a subtree is a binary tree, the binary tree. So a subtree of a binary tree, right, is a tree that consists of a node and tree and all of its nodes descendant. Okay, cool. They give us a very good explanation of that, right? What a subtree is, right? Okay, so let's look at the different subtrees we have here, right? Let's just make sure that we understand everything, right? So that's a subtree. Right, that's another subtree, right? That's another subtree as well, right? That's a subtree, right? This 4, right? This subtree rooted at 4, right? It obviously includes 4, 1, 2. There's all the values in the tree, right? And this is the tree rooted at 5, right? Doesn't have any children, right? So it's 5 alone, right? And he says that the tree can be considered a subtree of itself, right? So we're given 3. 3 is a subtree, I guess, right? That's what they're saying, okay? So the different subtrees, right? Right? So now what do we need to do? We need to find a way that to see in all of the different subtrees, right? Do we have one of those subtrees that's exactly the same as the subtree that's given to us, right? That's kind of the ultimate goal, right? We need to find, right? And it says that, they're identical in one way, right? Not by reference, right? But, they need to be structurally the same, right? And the values of the node needs to be the same, right? So if we can find a subtree that's exactly the same, right? Structurally wise, right? All the numbers are at the right spot, at the exact same spot, right? And all the numbers are, all the same, right? So that's kind of what we need to do, right? That's kind of the check, right? We need to make sure that there exists a subtree in this tree that's given to us, right? To see if we do find a subtree that's equivalent to this one, right, the same tree as this one, they will return true, right? If we don't end up finding that, we return false, right? So this example is very interesting, right? So we can see that one of the subtrees that we talked about, right, the subtree rooted at 4, right, is the equivalent of the subtree that's passed into us, right? We can say that there exists that subtree and the tree that's given to us, right? Okay, pretty easily. So this example is pretty interesting. So we see that we have the subtree given to us, right? 4, right? And we see that we have 4, 1, 2, right? But because we added the extra 0, right, we turn false, guy, right? Because even though the value is almost the same, right, it's not the subtree rated at 4 is not the same as this subtree, right? So this subtree must have been part of another tree, but that's not the tree right here, right? You know what I'm saying? So because of that, right, of this extra 0, right, this subtree is not the same as this subtree, right? It's different, right? We could visually see it, right? Even though the values are almost the same, right? Almost the same tree, but it's not, right? It needs to be exactly the same, right? It says that, yeah, because all the nodes, the descendant, play a role in the subtree, right? So that's what's important about it, right? So the tree we have 4, all of the nodes under it, right, play a role, right? So it's not exactly the same as this one. So that's interesting, right? So we kind of understanding a little bit now that we went through a couple of examples, right? Let's see, how can we go about solving it, right? That's kind of the most important part. How can we solve it? What kind of intuition do we need to come up with to solve this problem? Okay. What can we start with, right? So we know how to traverse, okay, binary trees, okay. How can that be help, right? So maybe we can just traverse, right? As we're traversing, right, the tree, right, we can do some kind of check, right? For every subtree that we encounter, right, we check, is it the same as this one, right? If it is the same as this one, then we return true, right? So the subtree rooted at 3, right? We check if it's the same as this one. Obviously, it's not the same because the nodes, the root nodes are not the same, right? So that's not even doesn't matter, right? So we go so now the next logical thing for us to do, right? Thinking is to check our children, right? To check our left and our right side. And hopefully, they themselves could find a subtree. They could be one of the subtrees that matches the subtree passed in, right? So we keep checking every time, guys. So we check our, so 3 is all right, cool. Obviously not it. So let me check my left side, right? So my left side is there, right? We check. So now we need to check our left side. So now we check, is this subtree rooted at 4? Is it the same as this subtree given to us, right? Right. So obviously you need to check. We're gonna need to worry about, we're going to need to have some kind of a utility, a helper function that's going to kind of help us in checking two subtrees, right? So 2 trees, right? We're giving helper function. We're going to give it 2 trees, right? And its job, right, is going to be all those 2 trees passed in, right? Are they the same, right? If they're the same, then we could say confidently, right? This is the thing that we're looking for. This is the subtree that we're looking for, because it matches exactly the same, right? And we've done a problem similar to that where we check if if 2 trees are the same, right? If they're structurally the same, right? Meaning that they're organized the same, right? They're structurally they look the same, right? And all the numbers as well, right? They are exact at the right spot that they need to be. The values are matters as well, right? So this is what it's going to do, right? So you can see the algorithm is going to be for every subtree we encounter, right? The root, we keep checking, right? If that, so we keep checking to see if the subtree rooted at that node, right? Is it the same as the subtree that's passed in, right? It's kind of the whole algorithm, right? So it's going to be very, very simple, guys, right? So what we're going to do, we could start off with the algorithm, right? So if root is null, right, we're going to return false. Okay. It's an empty tree. And what's next for us to do, right? We're going to check, right? If. So we're going to have some kind of helper function, right? We're going to use the exact same function as we use in the other problem, right? So very interesting, right? So if same tree, right? So what are we going to pass in, right? We're going to pass in the root, right? The tree, the root node rooted at that subtree, right? And we're also going to pass in the subroot that's passed in as well, right? So if this happens to be if they happen to be the same, right, we can return true, guys, right? That's the equivalent subtree we just found, right? So we just return true, right? If that's not the case, right, we're going to check our left and our right side to see if they themselves could find that, right? Like we said. Okay. So there's this function we're going to call again. We're going to pass in, right? So you're going to pass in on the left side, right? For the subroot, what are we going to pass in, right? We're not going to pass in subroot that left, right? It doesn't make sense, right? Because that's not what we're doing, right? We're this function that we're going to implement, right? It's going to be doing the checking for us, right? That'll be checking, right? For this root, like for the node rooted at this, with this node, right? For the subtree rooted at this node, right? That's what I meant to say, right? To see if that's the equivalent one, right? So we're going to keep passing in the subroot, right, to every function call, right? So that every subtree can compare themselves with the subtree, right? With this, right? That's given to us, right? So, and once we go left, we also have to go right, right? Just like that, we are in good shape, right? So what's next for us to do is to implement the same tree, right? So to recap right now, what I'm doing, right? I'm checking for every subtree, right? And we check for the node rooted at, so for every subtree we encounter, right? And we start checking, start comparing, is it the subtree that we want, right? If it is, then we are in good shape, right? So I'm going to copy this function, right, that we've already done before, right? Okay, and I'm going to paste it in here. And this function, its job is going to compare the different trees that's passed in, right, to check if they're structurally the same and all, right? So to recap, it just checks here, right, if they're both null. Obviously, it's a good case to return true, right? If one of them's null, right, and they're not null at the same time, we return false, right, meaning that they're not the same, right? And just like that here, right, checks the values as well, right? If they're not the same, return false right away, right? But if they're the same, we keep checking our left side and right side, making sure that the whole tree, right, is the same. Okay, so yeah, that's kind of the whole algorithm, guys, right? For every subtree we encounter, we do a potential check to see if that's for the subtree rooted at this node, right? Is it the subtree that we're looking for? If it is, return true. If not, we keep checking our left side and our right side, right? So let's see if we're in good shape, right? So let's see. All right, my spelling was wrong. My bad. Small mistake. Looks good so far. Let's press submit. Awesome, guys. We're able to pass all the test cases, guys, right? So if you guys found value and you guys understood the thought process and the logic, let me know that in the comment section, right? If you guys liked it and all, let me know that as well. Any suggestion you guys want me, like any question you guys want me to do in the future, let me know that as well, right? We can take that into consideration and try to do it in the future. So I want to thank you guys for taking the time to watch the video. If you guys found value, you like, and yeah, I'll see you guys in the next video.